Okay, so this morning we're going to do 2019 ordinary, or 2009 even, ordinary level intersection of solids questions. So here's the questions that you've been sent. So that's pretty much it. We'll set up all the basics. We start off by drawing an XY line. 90 is the height and 90 is the width of the plan, so it looks like there's loads of space. So we'll draw a line roughly in the middle of the page. Now, if we underline the key parts, we see that the peg is based on an equilateral triangular prism. So basically this is the block we're drawing. These bits here are just other parts of the thing, but not bits that we're drawing. And the given plan elevation project an end elevation of the block and the peg. So we need to do an end view as well as a plan and elevation. Now again, if it says plan, typically that's what we should start with, and show all lines of interpenetration. From having done this question before, I know I'm going to need a equilateral triangle here, and you'll see why in a second. But so I leave a little bit of space here, but we need space here. So we come down about halfway on the page, draw our XY line across, we mark it there, so, and we will, let's see, come in about 80. Alright, that should give us enough space for equilateral triangle here and enough space for an end view, hopefully. So we'll draw this to start. We'll leave a gap of 10 mil between our plan and elevation, and we'll start to create out the question. So we know 15, first size, then 60, then another 15. Okay, and then we know 15 to come in. We get that from the elevation, 45 for line 30. And then we need to look at, we can see there's a semicircle here. So if we know the width of this is 90, we know we come down 45. Alternatively, we could bisect that line. That should be a bit even more accurate. I'm going to draw this semicircle now. And if we look carefully at the shape and we try to break it down and say, well, what is this shape that's fitting within the semicircle? And we can see that it has 3 sides, and we can see that they're all of equal length. It's actually a semi-hexagon, so it's half of a hexagon. So the angle for hexagon is 60 degrees, the internal angle, but because it's on its side, that will be 30 degrees this way. And again, always a good tip is, even if you're unsure, just balance it. Just balance your set square against this, see does it line up at any angle. There you go, so 30 degrees. So we'll draw this like so. 30 degrees from the bottom. If we're accurate, the two of them should line up in a straight line. And then we have our bit continuing out here, and we can see that it comes out for another 15 after the hexagon. So we have to have that bit there done in order to figure out the length. Okay. So at this stage, in order to make sure that we got most marks, what I would do is I would then start to create out the elevation. The reason for this being, at least if I ran out of time in a question, I have a bit of the elevation and the plan done. Okay, and we'll come back and we'll heavy in some parts then in a second. So we go 20 up, and then we know 90 from the top. Okay. Okay, so hopefully we can see that, and we're not gone too far off. My T-square was just hitting off the top. So what I'm going to do is I'm going to heavy in some of the plan. So we'll just get our purple here, and we'll heavy it in with this. So if we look carefully at it, I also forgot a line here for the center. I'll draw it a bit light for the minute. So we can know that this is heavy here. Probably stand out a bit better for you to see it. Okay, so we'll find our lines of intersection in a little while, but for the minute at least we have an outline there we can work with. And if we look at the top part, we have an angle from here to here that I haven't put in yet. A solid line here, and I forgot this line here. So Okay, so our problem now is basically we have nothing here, right? We're unsure of the height here. But if we go back and we read the question, what we're told is basically this is the peg, so this is the bit that goes into the block, the children's play block, and we're told it's an equilateral triangle or prism. So what we do know is if we look down on top, well, we know the base of it is 60. If it's equilateral, all sides must be equal. So basically all sides must be 60. So what we need to do is we need to just draw a little side view here of the equilateral triangle. You may have seen this in previous questions that we've done, because in newer years what they've done is they've given you the hint of drawing a side view of it out here, and we'll mark out 60. So it doesn't really matter the gap as long as we have space. So we'll mark out 60. What we'll do then is we'll take our compass. Okay, so I'm going to use maybe a green. That might stand out a bit better. And we'll set a door width on the bottom. Okay, and we'll strike there. So now we know everywhere along that arc is 60 millimeters away from the point on the left hand side, and everywhere along this arc is along 60 millimeters from the right hand side. And so what we have now is basically our equilateral triangle. Okay, so I suppose another idea of what I could do in order to make it a little bit easier for you is this line here, I suppose, will be green. We'll make our block going through green. And we'll leave it roughly like that. And again, probably might make sense if I go over these a little bit. So basically it's a green block going through into a purple object. Okay, so what we need to do now is we need to find our various intersection points. And if we look at the question, it gives us loads of hints. So if we start with this side here, we know that this is going to come down to here and then continue on, and there's going to be a point here somewhere along that we don't know exactly where it is. There's going to be a point here somewhere along that we don't know exactly where it is. Right? So because they don't seem to stop at any given point and we're given no distances, we know that they're the two areas in elevation that we need to work on. So the first one is quite simple. So what we'll do is we look at this plan view. Okay, and what we'll see is that the point here hits my hexagon here somewhere, so I'm going to need that above. So if I bring this straight up, there we go. So that must be where the base of it hits in. So that's that. We can see why this is here, because this is where the top is. So again, the problem that we have is we don't know the depth down. So we might come back to that in a little while, but we'll just extend down this line a little bit. Okay, and we will probably need an end view in order to solve that. And there's an alternative way, but we'll probably use an end view. So that's as much as we can do for this part here for a minute. We have to do an end view anyway, so we'll use that as the easiest method. So what we want to do is, again, we want to look at this side. And again, we can see in this case they're solid in elevation, which means you probably don't have to do anything with them. But in plan, we have unknown distances. And again, if we look closely at it, we can see what we could do is project back down this line and project back down this line. And if we look at that, again for a hint, although we should probably be able to figure it out, that looks like where they're meant to be. So we'll mark them with our green. Just drawn across there just so that you can see them. So this would come up like this. This would continue on to here. Sorry, that's my T-square falling. And basically we have that. So we can now, this line here would be heavied in, and we can put in our hidden detail. So that's going to continue on through there. Back the other side. And hidden detail is very important. They show it on the question as well, so it would be foolish to end up an exam without having it done, because it's probably going to be simple math. So the last bit we have is just our right hand side of our elevation. Other than that, I think we're looking good, but we'll have a check at the end anyways. So what we want to do is we want to project over and up at 45. So we pick this here as our common line. I think we've everything out to that line anyway. Oh no, we haven't. We need to get these 2 points here as well across to that line. Okay. I think everything else has been brought up. Okay. again, a simple bit of creating, bringing everything across, making sure that everything intersects. If you run out of time on the day of the exam, by doing this method, you will have got quite a lot of marks. I'm just using my set square there so my t-square is hitting off the visualizer. So basically we have our end view, we have all our bits projected up, and now it's just a matter of working out the various things. So the first thing we need to know is, well, maybe we'll get the green triangle. So if we take this point here, that's the base, that's the other side of the base, okay, double check it, there's my center point. So there is my triangle. That's going to go through my object. Okay, so this bit here has something got to do with the hexagon. So what I'm going to do is I'm going to bring up the edges of the hexagon. I'm just going to highlight them in blue just because I used a little blue there. And that point and that point should technically be straight across from each other. Mine might be a tiny bit off, just from using the pencil, but they seem to be fairly close. If I bring that across to there, that gives me the end of this point. So basically I've brought these points across and found, and again when I use a bit more colour you might be able to see it a bit clearer, but that's basically this part here. Okay, so if I shade that, that's that, and that's what goes through on that side. Okay, so what I'll do is I'll finish off. So I want to get this block here, so basically the outline of it is a big purple, going to be a big purple edge. So we'll take that and we connect that in there. Now if we're looking at this view, we're standing here. So these edges here would be hidden detail because they'll be behind. And as I said, I'm going to keep them in a light blue just so that it's a bit easier to see. So because they would be behind, they'd be hidden detail. Okay, so a series of dashed lines there. And that's pretty much what I'd see. This will look like a solid block, this will look like that. That's my hidden detail here. If I look at my lines, I've used all my lines for something. So I think that's correct. I've brought it back across to here. So that's the question completed. I'll just double check here just to see is there any more hidden detail. So if I look at this edge here, I think this bottom surface here would require some hidden detail. Yes, it would, because if we look at it, that would be an edge underneath. Okay, and this edge here would be the purple surface in underneath. So I'll use a purple just to highlight that. We have our hidden detail across, our hidden detail across. So I think that's this view done. We look at this view here. Again, this is going through the object, which is a bit unusual because the hole is actually in it. Sometimes they don't expect you to mark in the hole, but because of what it shows from the question is the two can be slid in, we draw some hidden detail there. We have all this, again some nice shading here. I've done it very quickly, might make it a bit easier for you to see or show your understanding. And then my end view, as I said, we've double checked. So at that stage we're happy with that.